All right. Sorry to cut you short if you're still working, but we're going to go over this. So make sure you follow along and make sure devices are gone. Driving, right? Driving. Zero, right? Okay. Here we go. So unfortunately, all of these are based on like numbers or words. There are no diagrams here, no pictures, because remember there are three ways that I'm going to ask you to draw precision and uncertainty from. Okay, so in this case, if you have a highlighter, have that ready to go, right? The timer displays 1 minute increments, and you're setting it to 55 minutes. That is your precision right there. But you need to understand, like I'm going to talk about more than just putting down a number, because you need to understand, you've probably realized that I do a lot of explain types of questions. This is the limitation of your measuring device. You can only get it as close to the nearest minute. That's all you have, right? Anything smaller than that, you're just guessing, right? You're just like, I'm guessing this is about right. This is about in between, right? So uncertainty is half of it, so it's 0.5 of a minute. If you wrote down 30 seconds, would that be okay? Yes, it would be okay. But I'm just going to leave it like that. Here you have no indication of increments, no measurements, no markings. So you got to go by this number. You got to go by the value. And we're assuming, we're focusing on that one right there. We're assuming that this measuring device, it gets you to the closest tenth of a degree. Okay? And the uncertainty is half of that, which most of you, when I was looking, wrote down. So good. A jeweler weighs 1.243 grams of gold. Our assumption is that whatever he's using, he or she is using, is down to this, right? So 0.123, there's 3 decimals. So we're saying to the nearest, what would that be? 1,000th, right? You have your tenths, hundreds, thousands, right? I'm just making sure you hear that THS at the end. Okay, so half of that would then be that, right? That's your uncertainty. So what you're saying is, whenever, nobody does this in real life, but really, like if you hear of a poll of a survey that has been done, and 85% of teenagers spend 3 hours on their phone minimum, they're never saying plus or minus 2% or whatever it is. But if you actually look at the report, if it's professionally done, it will always have uncertainty to it, okay? It's never just black and white. There's always a little bit of leeway. 90% of us are vaccinated, right? In this region, is that always going to be exactly 90%? No, it's going to be more or less, right? So they don't tell you that because it's not cool to talk about it in those terms. Okay, next. A technician records the distance between two fence posts to be 1,200 meters. We're focusing on that last one. So this one is just to the nearest meter. If you don't get this after today, I don't know what to say. You have to review your notes, right? But we're assuming that the uncertainty is half of it. Okay, another thing I want to say, the greater the precision, so the smaller this number is, you actually have a high level of precision. The smaller your uncertainty will be. Does that statement make sense at all? The more precise you are, the less of a margin of error you're going to have, right? So you need to understand that. Next, 5. So now we have our word problems here. So we have a track and field meet, and the gold medalist won the 100-meter sprint. This is to trick you. I did that on the test too, the stats test, the 60 minutes or whatever that was, and some of you put it in, like you gotta be careful, right? It's this, the time we're focusing on. What was the precision of the timer used? We focus on that, and the precision is 0.01 of a second. Uncertainty is just 0.01 divided by 2, which is 0.005 of a second. Don't forget your units. A lot of units were missed on the test. Seconds, minutes, whatever it is, keep writing it down, right? What is the sprinter's time, including the measurement uncertainty? And what you need to do here is write down 10.23 seconds plus or minus its uncertainty. Yes, it's pretty accurate. It's very precise. Getting down to the point to the nearest hundredth of a second, but there's still some uncertainty that goes with it. It could be over or under by this much. And we're always assuming it's going to be half of what it's precise down to, right? Given the uncertainty, write the maximum and minimum times it could have taken for the sprinter to run the race. So the max is going to be 10.23. You need to show this, okay? The uncertainty. And the min is going to be 10.23 minus the uncertainty. So you're saying, hey, technically, this sprinter could have done, it could have actually taken a little bit more than what they're claiming, or it could have actually been that, oh, I gotta be careful here. I just want to show this. Use your calculator. If you're not sure, if you're dealing with decimals like that, 10.23 minus 0.005. That is 10.225, okay, of a second. So we're not rounding ever in this unit down to as many decimals as you have to. So you are in between. You know what this doesn't do? Anybody remember? Let's add this. What's the range? Anybody remember how to get the range? Max minus minimum. Yes, you remember that? I told you to put that on your study sheet. So it's max minus min, and I'm going to do it right next to it. In this case, choo-choo trains are okay. Right? Like you can do this equals to this equals to, you show the work. 235 minus 10.225. And that is actually your precision. It ends up being the same as your precision. You got to know what the range is. That's it for this page. 15 is coming up after my lesson. Okay. So get your booklets. Go to 87. Like if you were like, yeah, I got this already, like whatever. This is where you want to pay attention because this is now going to be different. Still working with the same things, just learning something new, a new concept. 87. So what you want to highlight here is adding and subtracting values with uncertainties. I really want you to have that highlighted and make sure you follow, because it's a new concept, right? So highlighter if you have one. So it says here, read carefully, when adding and subtracting measurements, right, they each have their uncertainty that follows them. Each measurement will have some level of uncertainty. The combined value will also have an uncertainty that comes with it. Okay? And here's the next one. The uncertainty of the final amount is the sum of the measured uncertainties. And the sum of the measured uncertainties we call, I will write it right next to combined uncertainty. In quotations like that. So you can't anymore in this unit be like, hey, somebody's buying 2 kilograms of sugar and another 3 kilograms of sugar. Let's just add 2 and 3 and that's it. You always have to think there's an uncertainty associated with those. So we cannot ignore that. I will talk a little bit about this here. I always talk about an airplane, or let's talk about Canada Post, right? A lot of us buy stuff from Amazon these days, right? And when you don't want it, you return it, right? You go, you print your label, put it on. What does the person do working at Canada Post when they take the package? Maybe, are you buying stuff from Amazon? I'm sure you're buying it through someone, I don't know. But when you bring it back, you bring it to them and they put it on a scale. And they weigh it and they enter that. So every package that comes in, somebody's weighing it and the system is keeping track. They're probably in the back putting it in like on a pallet and they're going to shrink wrap it and that all goes to probably like the central station where they sort it and whatnot. And it might go on a plane, right? Every time a package comes in, there's a little bit of uncertainty there. It could be off by a little bit, not much, but it does add up. And so when you go on a plane and you're off, right, they need to consider that when somebody says there's 250 pounds on this pallet, it could actually be a little bit more or a little bit less. Okay. Also, people on the plane, right? They always ask you how heavy you are. Like they ask you for your weight. They shouldn't do that. People always lie about their weight. Maybe they have like a platform that you don't know of that actually weighs you, so they bust you in your lie. Right? There's always some uncertainty, like when Yuri's going to come to class. We don't know, right? So he's here though. Good to see you, Yuri. Page 87. Okay. Let's write this down here. Weighing. Make sure you have this down because these are things that I test you on. Weighing all items, right, at once, okay, will have a lower combined uncertainty. Versus weighing each item individually. Page 87, Kirat. So if you had a choice of weighing the whole thing just at once, like the whole pallet, or taking each item individually and weighing it, if you would have a greater combined uncertainty because it keeps on combining, right? The uncertainty keeps on adding up the more packages you put on that pile. So you would want to just try to weigh them all at once, okay? So let's do an example already. So I'm going to get you to just, we're going to focus on that example 6 there. Okay, so here, Marcy is a carpenter. She's installing sheets of plywood as subflooring on a balcony. So plywood put on a floor. Okay, got it. She has measured 2 of the sheets to be 2.5 meters and 1.30 meters long. This is the part I want you to scratch here. Watch carefully. We're not going to worry about that part. That just gets way too messy. I just want you to be able to do what I'm about to show you here. So we just have these 2 pieces and they have different lengths. So you're putting them down on the floor, got it, okay? write the lengths of each plywood sheet as this measured value and their uncertainty. So we're going to just now not just write it down as they have given it to us here. We're going to have their uncertainty as well. So for A, we're going to, let's do our plywood sheets here. This is the one that's 2.25 meters, and a shorter one here that is 1.30 meters. Side by side, we're putting them. What's the precision? Do they both have the same precision? Both boards have the same precision? What would you say? That's the first thing you should identify. They both have 2 decimals, don't they? So the precision is 0.01 meter for the first board, and the uncertainty is 0.005. I will do the same thing for this board here. The precision is 0.01 of a meter. Uncertainty is 0.005 of a meter. This is a good practice because sometimes they have different uncertainties. Okay. So let's write it with their uncertainties. 2.25 meters plus or minus 0.005 of a meter, and 1.30 meters plus or minus 0.005 of a meter. So you've written them both down with their uncertainties. That's what they wanted. I'm going to cut this off right there, and I will do B on the side there. So we looked at the measurements. We were able to get the precision and the uncertainty for both. We now write the measurement with its uncertainty right next to it. Now B is asking, what is the total length including their uncertainty, right? Length and uncertainty if the 2 sheets were placed end to end. So like this. So we have like this, we have this one and another one right next to it like this. And what we do is whose music is playing? Let's turn that down, okay? We have these 2 here, side by side, and they're basically asking us, hey, what's the total length of this stretch here? What would it be? And in this case, we were going to have to add, correct? We would add the board lengths, 2.25. I will omit the units for now. It just makes it easier. Plus 1.30 plus or minus 0.005. So you set it up like this, and we're adding. Just like before, you would just add these up. Right, that's 5, 5, 3, 3.55 meters plus or minus. This one you might have to use your calculator for. Like, it depends on how strong you are with decimals. So if you're not sure, you can actually go times 2 if you want, right? But that's what the combined uncertainty is. And so this piece is what they were after. This is the combined length, right? Total length plus uncertainty, plus or minus that uncertainty, right? There's a combined uncertainty there. Okay, so you always add the uncertainties regardless of what the scenario is. You add the uncertainties up. One more example, and then you'll have time to work on your own questions. Okay. So I could have given an example with 4 different boards being added. You would have had 4 uncertainties that you would have added up to get your total uncertainty. Okay. And just keep that in mind. Next, Junior has a bucket with 20.5 liters in it. Okay, he needs to draw, that should tell you, right? Draw some water for some plants using a smaller jug that can hold 1.2 liters. If Junior draws 3 jugs from the bucket, determine how much water will be left in the bucket, including the uncertainty. Okay, so we're going to answer A here. And I'm going to focus on the 20.5 liter bucket. My precision is 0.1 liter because I need my uncertainty, right? Uncertainty is 0.05 of a liter. I'm going to box that in for now. So I focused on the bucket. I got the uncertainty for that one. Then I'm going to focus on the jug. It happens to be the same. It will not always be the same. But this one only has 1 decimal and it's in liters. This will be 0.05 of a liter. Box that in as well. And now we're going to do the math. So we grab our bucket and we're going to write it with its uncertainty. And we draw 1 jug out of it, which has, that jug has its uncertainty that follows it. We take another jug. It also has an uncertainty attached to it. And the third jug. So 3 things are happening here, right? 3 repetitions. It happens to be the exact same amount. So you go 20.5 minus 1.2 minus 1.2 minus 1.2, or 3.6, right? Some of you already figured that. 16.9. And we are in liters, so now I bring back my units. Plus or minus. These are all exactly the same, correct? So you have a choice. Go 0.05 4 times, or I'm just going to go ahead and multiply that by 4 to give me this. 0.2 liters. This is the combined, this is how much would be remaining. Okay? Remaining in bucket. So there could be a little bit more or a little bit less, but we now know there. Wait a minute. Nobody asked me this question. And maybe you are wondering, why did you add, Mr. Dirksen? Why did you add these, even though we are subtracting? And it's because the uncertainties keep on piling up. So every time you draw with the bucket, there's a little bit of uncertainty, uncertainty, uncertainty. So you always add the uncertainties. Got this? I will do this. Always add uncertainties. Always, regardless of whether or not this involves subtracting the actual measurement. We had to subtract the amount of liters because it's going down, but the uncertainties always get added. Okay. Hold on, there's one more thing here. Based on this, there's a max that can be in the bucket, a maximum amount, and there's a minimum amount. The max is 16.9 plus 0.2, 0.2, and the min is 16.9 minus 0.2. Okay. Plus, that would be 17.1 liters, and minus would be 16.7 liters. Use your calculator if you're not sure, right? Don't try to guess and then get it wrong. okay? So I just want you to know that when you're stating it like this, you can get the greatest and the lowest amount that is left in the bucket. So B, and then I'm done. And then you will work on this, okay? If junior still needs, that's what this is supposed to say. Let's say junior watered the plants and still needs 17.5 liters to water a tree. Will you have enough? Will you have enough water to water that? What's the maximum possible left? Right? This is all that there's left in the bucket. So no, since the maximum amount, I'll just go AMT remaining, is 17.1 liters. And you got that by actually stating these two here. Okay, so here are the questions I want you to work on. The first one, I want you to focus on page 15 in the workbook, worksheets, okay? When you're done that, which you should be done, you come back to this booklet and then you go to page 89 and you do questions 3 to 6. If you're able to do this today, you're in pretty good shape and you know what we've done today. You should be able to understand what we've done today. And the only way to know what to add